Okay, so what we're going to do now is try and tie some of this matrix information into our transformations. Okay, so what we're going to talk about now is I've got the point x, y, and then I apply some transformation to it. So if you like x dash, y dash, if I apply some sort of transformation to the point x, y, how can I do that using my matrices? All right, so this here, 1, 0, 0, negative 1, if I apply that transformation to the point xy, okay, so the top row is going to be the x value, the second row is going to be the y value. What does this become? It's equal to 1 times x plus 0 times y, which is just x, 0 times x plus negative 1 times y, which is negative y. So what happens here? The y value is now negative. That's a reflection, isn't it? So that means my y value goes from up there down to here. So we call it a reflection in the x-axis. So that's what that negative 1 there does. All right. What happens if I do that? What happens if I do negative 1, 0, 0, 1 times some point xy? I get negative 1 times x, which is negative x, plus 0 times y, which is 0. And then I get 0 times x plus 1 times y, which is y. So what happens here? The x value becomes negative. So the x value comes from there and it goes to there. So that's a reflection in the y-axis. So that's what that does. So that value there affects my x-coordinate. And if my x-coordinate becomes negative, it means I reflect about the y. Similarly, if I multiply by a factor, if I have 1, 0, 0, k times x and y, what do I end up with? 1 times x plus 0 times y is just x. 0 times x plus k times y is ky. So my y value got affected. So if the y value gets multiplied by k, it goes from there and it stretches up 2 times, 3 times, k times. So with a k value here, it causes a dilation by a factor of k from the x. So again, the k value in that position affects the y coordinate. And if the y coordinate gets dilated, it moves from the x-axis. And hopefully you can see that a k value there, the k value there affects my x coordinate. And if my x coordinate gets affected, it's dilation from the y-axis. All right. So really, in some ways, you might think you have to remember all of these matrices. All you really need to remember is if I'm talking about this top left corner, it affects the x coordinate. If I'm talking about the bottom right corner, it affects the y coordinate. That can help you determine what sort of a transformation's taken place. The last one I want to look at, and it's one we don't use often, to be honest. If I've got the ones in those two corners instead, I get 0 times x plus 1 times y, so I get a y value, and then in the other value I get 1 times x plus 0 times y, and I get x. So what happened here? The x value became y, and the y value became x. So what happens when you make x equal y? Well, that's finding our inverse function, isn't it? So that's the inverse. And when we find an inverse graphically, hopefully you can remember that my inverse graph, so if that's x squared, The inverse graph, as you remember, is a reflection about the line. So that's the line y equals x. And so the inverse is the reflection about the line y equals x. So to keep it in terms of reflections, dilations, etc., we say that this particular matrix here, you could say it creates the inverse function, but in terms of dilations, translations, it's a reflection about the line y equals x. All right. I don't really like that first example. Let's go to example 12 first. All right. This is a specific question in the book. So let's go to question 12 first, example 12. Find the image of the point 2, -4 under the following reflections, dilations. So first step is my transformation matrix. Okay. It says under a reflection in the y-axis. So if it's in the y-axis, it means that the x value was affected. And if the x value is affected, that's a negative over here. Okay, so reflection in the y-axis is a negative at the start, followed by a dilation by a factor of k from the x-axis. So from the x-axis means the y value is affected, and if the y value is affected, that means the k value is down there in that bottom right corner. So that's the transformation matrix. All right, I'm going to apply that to the point -2, 4. And if I do the multiplications, -1 times -2 is 2, plus 0 times k is 0. And then I get 0 times -2 plus 4 times k. So that's what's happened, all right? Therefore, the point -2, 4 becomes the point 2, 4k, all right? That's what that means. If we do this previous example, we have to find the matrix transformation. That's what we really need to find first, okay? So my matrix transformation or transformation matrix is some A, B, C, D. And what that tells me is, what this tells me here, if I apply that matrix to the point 1, 0, I get the point 2, -1. Yeah? So if I multiply this left-hand side, if I multiply it out, I will get A times 1 plus B times 0, which is just A. It's the end of that row. Go to the bottom, I get C times 1 plus B, D times 0, which is C. And that's equal to 2, -1. So you can see straight away, I can now see that A is equal to 2 and C is equal to -1. If I do exactly the same thing, the same matrix applied to the point 0, 1 will become -3, 5. So again, expand the left-hand side, I get A times 0 plus B times 1, which is just B. Then I get C times 0 plus D times 1, which is D. And that's equal to -3, 5. So straight away, I hopefully can see that my transformation matrix, I've got the A, B, C, and D values. A was equal to 2, C is equal to -1, B is equal to -3, D is equal to 5. And that's my transformation matrix. And so then I need to find the image of, or the transformed value of -2, 3. So if I apply that to -2, 3, which was the last part of the question, what does the point -2, 3 become? It becomes 2 times negative 2 plus negative 3 times 3. So 2 by negative 2 is negative 4. Negative 3 by 3 is plus 9. And negative 1 times negative 2, which is 2, plus 5 times negative 3, which is negative 15. So it becomes the point, negative 4 plus 9, which is 5. 2 plus negative 15 is negative 13. Yeah? So therefore, the point negative 2, 3 becomes the point 5, negative 13. All right? Okay, that covers the large part of the transformations there. All right?